The Perseid meteor shower, sir. This is going to be quite a show.
Well, we hope so. So once a year, the Earth and its orbit goes into a swarm of what we can only call cosmic garbage. If you don't want to call it garbage, you can call it debris, which is a fancy name for garbage. But there's an old comet that's left behind a bunch, literally, of dirt in space. And every August, we encounter that swarm of dirt. And as the dirt burns up in the Earth's upper atmosphere, you get what's called a shooting star or a meteor. And we're going to have that exact event, the meteor shower, this weekend. It's especially good Sunday night and Monday morning, but it'll be good on Saturday night too. So if you're in a dark place, somewhere away from city lights, away from the fog, look up this weekend and check out the sky. You're much more likely to see shooting stars than usual.
Well, when you ask if I'm in a dark place, for me, I'm always in a dark place. But now I realize you want to get away from city lights. And since it's an annual event, what elements actually and what variables influence how good it will be, how visual it will be?
Well, so this is a comet called Swift-Tuttle, which goes around the sun in about 130 years. And so it's whenever we're in the thickest part of the left behind debris, you get more shooting stars. We're not in a particularly thick part this year. And the moon, if it's in the sky, its light can interfere with seeing the faint flashes of light. And you're going to have moonlight this time around until about 11:30 or midnight. So it's even better for the night owls who can get up after midnight. But still, you are much more likely to see shooting stars this weekend than you normally do in the evening sky.
All right. So, and if you can get out there after 11:30, into when the moon is gone, in a sense,
Right.
you should have until dawn to see this
That's
stuff.
right. That's
Wow,
right. Yeah.
that's
Whenever
pretty
it's
great.
dark, but just think of it like in the cartoon, in the Peanuts cartoon, there's a character called Pigpen. And wherever Pigpen walks, you see a stream of dirt behind him. And think of it that way, that we're just encountering that dirt. And throughout the night, and probably Saturday and Monday night too, you'll be able to see the results of that encounter.
If I drive, says Michael, 30 miles out of town, I can see everything. I can see the Milky Way. Is that right? Are we 30 miles in one direction away from being able to see the Milky Way?
Well, you have to figure out which 30 miles. If you drive
Right,
to San
exactly.
Jose, you're going to have as many lights as you did in San Francisco. But if you get out into the country and you're able to really let your eyes get dark adapted, which I would give you a 5-10 minutes minimum just to let your eyes get adapted to the dark, just like in a movie theater. Then, if you have a clear sky and you look up, there are so many things you can see in the night sky that you can't see in the city, including the thickening of our galaxy in what we call the Milky Way.
As Professor Fraknoi, says John Watson, what happened to that periodic nova that was supposed to happen? Did I miss it, or is it still coming?
Yes, so a nova is actually an interesting phenomenon in astronomy. It's a double star. It's two stars that live together. And one of the stars is kind of almost like a corpse of a star. And the living star dumps material onto that corpse until the corpse flares up briefly. And that's called a nova. And there is a nova that's coming, but it won't be the kind of thing which you can see with the naked eye. It's something at the very edge of visibility. So astronomers will be excited about it, but it's not something that the average person is going to have a sense that it's happening in the sky.
In the tips from Professor Fraknoi, hints for taking a meteor shower in, you mentioned don't use a telescope or binoculars because they limit your field of view. This is one of those situations where you can just lie out, take in the whole sky.
That's right. I always say that meteor showers are for the 99%, not the 1%, as Bernie used to say. Uh, that you don't need fancy equipment or expensive things. All you need is your eyes and an ability to see as much of the sky as possible. So if you're out in the wilderness, but there are trees all around you, you won't be able to see the sky. But if you can be out on a field and lie back or sit back in a chair. Let your eyes get adapted to the dark. Have the whole sky in front of you like the great natural screen that it is. Then you're much more likely to be able to see shooting stars because they could happen anywhere in the sky.
William is asking, ask Andrew how reliable. Oh, there you go. There's a shot of, what is that? That's the night sky the way it would be,
Well,
looking northeast at 11. Okay.
right. So this what we're seeing here is something that's a little bit misleading for the average person. So we call this the Perseid meteor shower because if you could trace back the line of all the shooting stars, the different lines would meet in the constellation of Perseus. So it's the Perseid meteor shower, but they don't actually happen in that constellation. They can happen anywhere in the sky. So people think I need to be able to see the constellation of Perseus. No, you don't. You just need to see the sky, and then anywhere in the sky there could be the shooting star.
Now to another kind of visual phenomenon in the sky, which is really quite spectacular as well. Ask Andrew how reliable the 27-day cycle is in predicting the aurora borealis. That's a
Ah,
totally different phenomenon, the aurora
that's
borealis.
right. So let's talk about that. So if you've been to Alaska or Finland, places that are really north, you know that there can be a beautiful curtain of light in the sky, a kind of flickering curtain of color in the sky, which is called the northern lights or the aurora borealis. And people often wonder, where does that come from? It turns out that it comes actually from the sun. The sun produces a wind, an actual flow of particles coming from the sun. They encounter the rest of the solar system. They move at about 1,000,000 miles per hour, these particles from the sun. When they encounter the Earth is protected by what we call a magnetic field, a kind of magnetic bubble that envelops us and protects us from radiation and particles from space. But the one place the magnetic field comes in is the North Pole, and in our southern hemisphere, the South Pole. And so when you go up north, the place where the magnetic field allows particles from the sun to come into the atmosphere is near the North Pole. And that's when you get to see the encounter between those particles, those energetic particles from the sun, hitting the air and making the air glow in these curtains of light. So that's what normally happens. You have to go pretty far north to be able to see this. But when the sun is super active, when there are storms on the sun, then the sun can produce so many of these particles hitting the Earth's environment that they overwhelm the magnetic protection that the Earth has. And these particles then come in much further south. We had that happen this May, that there was such a series of storms on the sun that people in the United States began reporting seeing the aurora, seeing these curtains of light. And it has nothing to do with a 27-day cycle, but everything to do with an 11-year cycle. Every 11 years, the sun gets more active. And in 2024, 2025, we are reaching what we call solar maximum, the greatest activity, the greatest storm activity on the sun for 11 years. And so we may well have in the next year more examples of this, where the great curtains of colored light dancing in the night sky make their way much further south and might even be visible in California. Stay
Wow.
tuned, as we say on the radio.
Stay tuned. Um, so this sun violence that's associated with the kind of hugely active sun that you're talking about, this is going to permit, potentially anyway, northern lights to get to places that northern lights might not, where the cycle not so active. And will
Exactly.
it affect things like communications as well, or these sorts of things that we count on now, satellite communications, et cetera?
Great question. So, absolutely, this is the fear that scientists and the government now have, is how delicate the instruments are that we have in space against the kind of powerful storm of particles from the sun. These are charged particles, so they carry an electric charge. And so, yes, there is a great concern that if we, for example, depend as we do on satellites in space to give us GPS information. You know, those maps in your phone and the maps in your car that let you get to the right place without ever needing a physical map anymore. Those GPS measurements depend on satellites in outer space. If those satellites are overwhelmed by charged particles from the sun, they may stop functioning for a while, and that will throw off the GPS measurements on Earth. You may not be able to figure out exactly where you're going, which is not such an important thing for everyday life so much, but for military operations, for example, which depend on this, and airplanes, which depend on GPS, this could be a serious business. And we've actually had to ground air traffic during solar storms in the past. So there is a great concern about that. And then if there is a huge mega storm on the sun, it can actually play with the power grid, the electric power grid. So many charged particles come down to Earth, come down to the surface, that they actually begin to influence the power grid. And in 1989, the Canadian power grid was thrown off, was actually had to be shut down because of the solar storm. So this is we now have a solar space weather prediction center that's part of the National Oceanic and Atmospheric Administration. And that's the part of the government that every day keeps track of storms on the sun, precisely because of the questions that you asked.
It keeps track, that part of the government does, but is there much that we can do? Not we, I understand for major systems of the sort that you're talking about, there are systems within government, instruments within government to handle that for U.S. communications, military communications, this kind of thing. Is there anything you can do, or are you sort of at the mercy of the fates?
Yes, absolutely. You're at the mercy of the sun.
Yeah.
Nicely put. Absolutely. So, luckily, this kind of mega storm is very, very rare. Uh, we had one in the 19th century in 1859 that actually overwhelmed the World Wide Web of the time, which was the telegraph system. And there was so much electricity, the telegraph began to actually shock the operators as they were sitting on their keys typing out the telegraph messages. But it's very rare. It's once every couple of hundred years we have a superstorm like that. And then we have smaller storms that have temporary effects. But no, there's nothing right now that we can do. There's talk of hardening satellites, of enveloping them with material that will, in a sense, absorb or insulate them, but that would add to their weight, and that would make satellites much more difficult and expensive to launch. So there's that trade-off, and we're still at the very infancy of knowing how to deal with the effects of the sun in that way.
When you talk about these things that happened long ago and then now the effects, like the Big Bang or energy as it passes through the universe and from one within our galaxy and ultimately down to us, how we all are made of a bit of a star of stars, and it's so fascinating and wondrous and romantic, and I wonder about, as many have wondered, other beings in other places, and the law of averages, just the numbers would suggest there has to be something. But this gets me to my question. The more I read, the more I'm persuaded, and this is why I need to ask you, because you really know, that what happened on Earth was in a way unique, in that the electronic exchanges, the chemical exchanges, the process of evolving was so specific that it would be very unlikely that any other place in the universe, even given the law of averages, you would find creatures who actually are just like us. Would you agree with that?
What you're very eloquently describing is called the rare Earth hypothesis.
Oh,
That the Earth is rare, that the number of factors that contributed to Mark Thompson Show listeners coming into existence was such a large number of coincidences and unlikely things that it won't happen anywhere else. And the only way we can answer whether that's a reasonable hypothesis is by searching for our counterparts among the stars. There's no way to know just by sitting here how likely we are. We have to figure out how to search for other beings. And the good news is that this is now happening. It's happening in ways that it's never happened before. I have the privilege of serving on the board of something called the SETI Institute, the Search for Extraterrestrial Intelligence Institute, an organization in Mountain View that is dedicated to the search for life in the universe.
remember doing a profile of SETI for NBC in the Bay Area. It was Cron back then. In the 80s. And it's wild that decades later, they're still going, probably with far more sophisticated technology.
We're celebrating our 40th anniversary. And I just want to mention that just in the last year, a high-tech leader has given the Institute over $100 million to expand and speed up the search for possible messages from other communicating civilizations. And so in the next few years, you will see a remarkable uptick in our ability to use telescopes to try to tune in on messages and what we call techno-signatures, signatures of technology. So this will be a topic we can discuss for years to come.
I'd love it. I remember being told as I was down there at SETI that the universe is a noisy place. Like you tune in that scope that they've got. I mean, now with the new infusion of money, these scopes are incredibly sophisticated. But the trick is to tune out a lot of the noise, right, Professor Fraknoi?
Exactly. The universe gives off not just lots of light, but lots of radio waves and infrared and other kind of waves. And finding a signal, finding something intelligent, like the Mark Thompson Show, for example, coming from another world, that would require us to be able to essentially filter out the static, the everyday noise, and look for the signal, look for the sign of technology and intelligence. And that
I have only one more minute with you, but it's always such a pleasure, and you can see in the chat everybody loves you and loves our time together. So, is there anything happening with the telescope, the
James Webb?
Yes, exactly, the Webb telescope.
Well, it's funny you should say that, because that's exactly one of the aims of the James Webb Space Telescope, is to see whether the building blocks of life, the chemicals that you talked about that went into making us, are common or not on planets or on other stars. And in the last year, we've established at least 3 or 4 planets that have sophisticated chemicals, which are the building blocks of life. And we can't establish life itself, but just some of the chemistry that led to us seems to be happening on other planets. So that's one of the things that James Webb can do that no other telescope can do: read the chemical makeup of the atmospheres of stars, of planets orbiting other stars.
That's remarkable. And just to be clear, the point I was making was that there can be life, and I think that I would suggest the law of averages is there has to be life in just absolutely lots of life probably in the universe. But what I was arguing is it just seems like the very specific situation that existed on Earth, it took so many different things coming together that whatever life is out there wouldn't be like this. That's what I was arguing.
Yeah, they may not look like us. They may have 9 ears and 22 eyes, but that's okay. As long as they communicate, we'll be glad to talk to them.
Exactly. Look, I love talking to you. Andrew Fraknoi, the Emeritus Chair at the Astronomy Department, Foothill College, teaching at the University of San Francisco and San Francisco State. And of course, his OpenStax astronomy textbook is a great way for people to get an astronomy textbook for free. That's what OpenStax is all about. And I love that Andrew Fraknoi is involved in that as well. Kim, did you have something on our way out?
Yeah, I don't know, quickly, I read that we're going to have a blue moon in August and maybe more than one. And I wondered what that meant and when we might be able to see it.
Right. So blue moon just means now. There were many definitions earlier, but it means a month when you have two full moons. We have 30 days in a typical month, but it takes 27 days for the moon to go from full moon to full moon. So sometimes you have two moons, two full moons in the same month, and that's what that's about. So
Got
that's
it.
not
Okay.
especially rare. We get two full moons in many months, but when that happens, they call the second one a blue moon. Has nothing to do with the color or anything like that. But that's what you're asking.
Awesome. Thank you.
I love our time together. Let's do it again. See you at the Perseids, and we'll compare stories after it's done. And Professor Fraknoi, what can I say? Everybody adores you, and I do too. Thank you for being part of things today.
Thank you so much for having me.
Bye-bye. Hi, it's Mark, and I thought that was great. Hit the notification bell. You'll know whenever there's a new video being dropped, and please subscribe to our channel to help us save the universe.